used to clamp down on those jaws, that it's located at the right position, which would be the front of these jaws, so you would spring the jaws. You take the spring out of it in any play. So when you bore those jaws, they'll run nice and true and concentric to the center line, and when they're in a relaxed state, they'll be true. But here's a few talking points. We have been contracted to make multiple titanium pressure vessels. It makes no sense to make these parts using a 4-jar chuck. Indicating the parts will be time-consuming and become a horrendous task. You also would run the risk of damaging and distorting the titanium pressure vessels. And why I'm saying this is with a 4-jar chuck, instead of a scroll, you got an individual screw driving each jaw independently, and you can exert a lot of torque and force. As the same can be applied to any chuck, you can overexert an excessive amount of force and distort pieces. But a 3-jar chuck, our point being is that it can be used very accurately and to save, time in setups. With a 4-jar chuck being independent, you got to put every part in there, indicate it in, make sure it's parallel to the spindle line, get it running somewhat true here, get it running true out here. It's a lot of hocus pocus to go through that's unnecessary. And by these facts that we're presenting you, we can show you, or we are going to, a cost-effective way to do something that's accurate and optimum repeatability. The tolerances are too close to take a risk. An excellent set of board jaws would make the task cost-effective and very desirable, like I mentioned previously. The jaws would have to be very deep to hold these parts securely. We made some very deep custom jaws that are equal to the task. This is the technique we use to make sure that there are no spring in our board jaws. And over in the back of the lathe, we have the parts that I'm talking about that we are going to be holding and demonstrating how we bore the jaws, and we can show you how accurately and securely they are held. What we're showing you here are 6 titanium pieces that are ready for board jaws, and there are more to come. Now what you see, these are the custom soft jaw blanks that we made to hold the titanium pressure vessels, which are made out of hot rolled steel. You can see from the face of the chuck jaw to the back, where it gets bolted to the master jaw and the chuck is 5 inches deep. And also, this is the face of one of the jaws. On all 3 of them, we have centrally located a 1/2 13 tap hole specifically for our custom boring ring that we're going to be using to bore these soft jaws. Now what we're going to do is we're going to assemble the custom-made soft jaw on the hardened master jaw, which will be inserted into the lathe chuck. As you can see, there's 3 jaws. I've numbered these jaws because the master jaws are numbered. This is done for a specific reason. In the event you take these off and you put the jaws back on, they go with a specifically numbered jaw. This is number 1, number 1. We'll go back to number 1 for repeatability purposes. Now we're going to take it and assemble it. This is the back of the soft jaw. We're going to flip it up. We're going to take the hardened master jaw, which has a key, and also this body of the jaw acts as a key here longitudinally. And as you can see, it's a nice snug fit. I just tap it in. I'm going to flip it over again now. And there's some socket cap screws here that are long, that go through the face here, that get bolted, that bolts this custom-made soft jaw to the hardened master jaw. And I'm just going to snug these up for video purposes when I get them on the chuck. I'll make sure they're torqued down to specific spec torques. Now, as you can see, it's bolted on. All right, now here we are, folks. We have the custom-made soft jaws mounted to the chuck, and they're torqued down. And now we're going to show you how we bore jaws the right way and the only way. As I stated before, you can see the 3 holes in the face of the jaw. The middle one in each one of these jaws is a 1/2 inch 13 tapped hole. And this is going to allow us to attach this custom-made boring ring that we made to bore those jaws accurately, and that's going to allow those jaws to spring outward. Let's mount this up. We have 3 holes here, equally spaced. I'm going to start by taking this cap screw and putting it in here. Tighten it down. Also, I got some heavy machine washers. I'm just going to put them in there. I'm not going to tighten them up yet. Like I said, they're just snugged up against the face of this boring ring. Alright, now, like I said, we have the custom-made boring ring bolted to the face of the custom-made jaws. We've snugged them down. They're not tight yet, so we can allow, when we tighten down the chuck, we're going to preload those jaws so they spring outward. And I'm going to apply a good amount of torque, as if the same amount of torque that I would apply on clamping down on the parts to be machined. Now we're going to go back and tighten these up. I'm just going to double check them. Now we've bored the jaw boring ring to a true diameter, and we're going to measure it. But this diameter is already larger than the finish OD of the parts that are going to be boring this diameter of these jaws to. So let's measure the ID and see what we have. I'm using a pair of inside mics here. Now we're right on. Now what we're going to do is, we know this diameter, and this tool is in relationship to this diameter, which I've set a 0 on the cross side of the lathe with an indicator. Now we're going to look at my drawing and see what the finish OD of the parts are, so I can bore these jaws to the correct ID, to the correct diameter. And I'll know how much to move. I've established my reference point. What we're doing now is we're taking a light boring cut after we've established a known diameter, so we know where the tip of that tool is. And what we're doing is, like I say, taking a light cut on the ID of the jaws, which we painted up with red Dykem. And by doing that, that'll show us that we are flexing the jaws towards the end here outward. And it should show like a slight taper as the cut, it'll fade away as it gets towards the chuck face. As you can see now, we're looking down through the chuck between 2 of the jaws on one of the jaws that we're actually boring. You can see we got the results we were looking for by our boring ring plate that's bolted to the face of the jaws. It sprung them outward. And how you can tell this? We painted the jaws, as you can see right here, with red Dykem to highlight the difference. You can see at the beginning, the width is narrower than at the back. This is wider. That's telling you that the front of these jaws are a larger diameter than the back part. That means they're sprung